but everything that's closer to this point than this point is already closer than it is to this point. So I can ignore that for the same reason I can ignore that. Just by inspection, I can also ignore these two things. So basically, halfway between these two, and the line that kind of went like that. And this region is already outside there, or already included in there. Okay, similarly down here, we don't even have to, at this point, I don't think we even have to draw it all out. The set of points closest to this are governed by those boundaries. Let's figure out where these boundaries are. This is the line y equals 0. This is what? Line x equals 2. Okay, these two, halfway between these two lines, halfway between those two, halfway between those two, so I still have this x equals 2 line. So set of points closest to this point are governed by this box, where this line is x equals 0, this line is still y equals 0, and this line is x equals 2. And similarly down here, that's the set of points closest to here. This is the set of points closest to here. What's this line? What's this line here? X equals -2. And here I have y equals 0, x equals -2. And here I have y equals 0, x equals -2. So that's my set of Voronoi regions. So basically, it doesn't really, what really matters here is the shape of the Voronoi region and the location of the signal within it. If I take this entire region along with this point and move it anywhere, basically all I'm doing is I'm translating the coordinate system. So all that really matters is the shape and the location of this. So in other words, basically, if I look at this, I have 4 Voronoi regions of this type, those 4, and 4 Voronoi regions of this type, 1, 2, 3, 4. So let's call this a type 1, and let's call this a type 2. So the type 1 Voronoi regions, probability of error, given type 1 is equal to, actually let's make this more precise. Let's call this guy S0. So the probability of error given S0 is 1 minus A times B, where A is equal to 1 minus 1/2, or C, alpha I minus x min over root. Let's let n0 over ts equal 1, so we don't have to deal with the denominator. C, alpha I minus x min minus 1/2 x max minus alpha I. Okay, for x0 in particular, what is alpha I? Alpha I is the x coordinate, which is what? No. 3. It's located at 3 in the x coordinate. So alpha I equals 3. What is x min? 2. It is 2. What is x max? It's infinity. So this box is unbounded to the right, and I allow that. So x min is +2. X max is infinity. If I plug that in, I get 1 minus 1/2 C alpha I, which is 3, minus 2, which is 1, minus 1/2 of, oops, this should be Earth C. 1/2 Earth C infinity minus 3, which is infinity. Earth C of infinity is what? 0. So this is 1 minus 1/2 Earth C of 1. Okay, the B term is the y direction. 1 minus 1/2 Earth C beta I minus y min minus 1/2 Earth C y max minus beta I. So it should be pretty obvious that beta I is +1, y min is 0, y max, yes?
Is there a reason why you have not included that, like, divided by square root of n0 over ts?
Yeah, I just assumed that it's 1.
Oh,
Beta I minus y min, that's Earth C of 1. Earth C of y max is infinity, so that's Earth C of infinity, so this is 1 minus 1/2 Earth C of 1, and we get this is equal to 1 minus 1/2, 1 minus 1/2 Earth C 1 squared. Okay, how about type 2? Let's call this an S1. Type 2, again, we have probability of error given S1, which is 1 minus A times B, where A is the error probability in the x direction, so that's 1 minus 1/2 Earth C, alpha I minus x min minus 1/2 Earth C x max minus alpha I. Okay, now alpha I is equal to what? The x coordinate, which is 2. No. What's the x coordinate? Plus 1. What's x min? X min is the minimum value in x of the Voronoi region, 0. And x max is 2. So we get 1 minus 1/2 Earth C. Alpha I minus x min is 1 minus 1/2 Earth C. X max 2 minus 1 is 1, which is 1 minus 1/2 Earth C. Actually, 1 minus, not 1/2, 1 minus Earth C of 1. Now B, okay, let's take a look at B. In B, beta I is +1, the y coordinate here. X min is y equals 0. X max, or excuse me, y min is 0. Y max is infinity. We already solved that problem. This is equal to 1 minus 1/2 Earth C of 1. So the type 2 error probability is 1 minus Earth C 1 times 1 minus 1/2 Earth C 1. Okay, how do we put it all together? So I'm arguing that the probability of error, so if this is S0, S1, S2, S3, S4, S5, S6, S7, let's say, probability of error given S4, I'm arguing is the same as S0. I'm also arguing probability of error given S3 ascent and S7 ascent are both the same as S0. Why? Because these Voronoi regions have the same shape. All I'm doing is I'm rotating it around and translating it in space. Similarly, I'm saying S1, S2, S5, and S6 have the same error probability because all I'm doing is rotating it in space and